Hello friends and my dear students, I welcome you all to my channel. If you are new to this channel or not yet subscribed, I will highly request and suggest that you support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I have seen that most of those viewers who watch my videos are not yet subscribed. Like 90% or 98% of the viewers are not yet subscribed. If you are watching my videos on regular basis and if my videos are beneficial to you, then please support me by subscribing to my channel. That way it will help me grow my channel, and it will also motivate me to come up with this kind of videos on regular basis. Thank you. Okay, this video is part of the playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. So this is part 4 on the subtopic Laws of Exponents from the chapter Exponents. This is class number 5. If you have not watched the previous 4 classes on the chapter Exponents, I highly suggest that you first watch them and then you can continue watching this video. This is part 4 on the laws of exponents, where I will discuss about how we compare numbers in exponential form. So we will do comparison of numbers in exponential form, whether one exponent is larger than another or equal or smaller, and we will solve a few problems from some external source. So let's get started. Okay, so I have, as usual, my notes on the exponents. These are the old notes that I have used in my for the last 4 or 5 videos on the exponents, laws of exponents. This will be used. These are the basic laws of exponents, and for comparing numbers in exponential form, let's discuss some fundamental concept. Okay, so if we have two two numbers in the exponential form, let's say a to the power m and let's say b to the power m. If we have these two exponents where the exponent, that is power, is the same m but the base are different, then we say that a to the power m will be greater than b to the power m if a is greater than b, and similarly a to the power m will be less than b to the power m if a is less than b, and of course a to the power m will be equals to b to the power m if a equals to b. So this is one concept that we must know or understand regarding comparing two numbers in exponential form where the exponent or the power is same but the bases are different. Now this is one thing. Another thing is that when the bases are same but the powers are, or the exponents are different, exponent or power or index are different. So let's say a to the power m will be greater than a to the power n if m is greater than n. Similarly, a to the power m will be less than a to the power n if m is less than n, and of course a to the power m will be equal to a to the power n if m equals to n. So these are the fundamental formulas or concepts that we need to keep in mind for comparing two numbers in exponential form. And yeah, I think these are the main concept that we need to keep in mind. Okay. Okay, so let's solve few problems based on this. Now over here the numbers a and b, they are of course non-zero numbers, and they can be an integer or a rational number. But m and n are integers. M and n are yes, m and n are integers. Now let's try to solve using this concept. You can take a screenshot if you wish for reference. Let's try to solve few problems. Okay. The first one says, which of the following is not equal to 4096? So it's an MCQ question. Which of the following is not equal to 4096? And we can see that the options are all numbers in exponential form, where the base are some 2, 4, 8 and 16. Now the strategy is that we will have to express 4096 it's better we convert everything as a power of 2. So 4096, if we do prime factorization, 4096, we have 2, 0, 48, and then 2, 1, 0, 2, 4, we have 2, 5, 1, 12, and I think it was better if we had divided by 4. Let's divide it by 4, because dividing by 2 will be a long process. So let's divide by 4. This is 1, 0. This is 1, 0, 24. This is 2, 5, and how much? 258. No. 8, 256, again 4, 6, 64, 4, 16, 4, 4, 4, 1. So 4096 is 1, 2, 4, how many times? 4 multiplied by 1, 2, 3, 4, 5, 6. So 4 to the power 6, and 16. Mm, 16. We have 8 is not equal to. Which of the following is not equal to? Okay. So this is 4 to the power 6. So definitely we can see that B is equal to 4096. This is, of course, B's given choice is 4 to the power 6. Now how much is let's see choice A, that is 2 to the power 12. We want to have 2 to the power 12, we want to convert it with the base 4. So I need 2 square, this will be 2 square to the power 6. So I have splitted the power 12 as the product of 2 and 6, and we know that A to the power m whole to the power n equals A to the power m and n. Using this concept, from A to the power mn, we have factorized mn into m and n, and we have written as A to the power m whole to the power n. So 2 to the power 12 equals 2 square whole to the power 6. Okay, now we see that this is 4 to the power 6. So option A is also 4 to the power 6. Option B is already given 4 to the power 6. And let's see what is C. C is 8 to the power 5. Now clearly, now which of the following is not equal to 4096? Now we can clearly see that it was not necessary to do all these calculations, because 4096 we know that it can be expressed as some power of 2, and as a power of 2, and all the options A, B and C can also be converted as a power of 2, but only C we cannot convert a to the power 5, we cannot convert a to the power 5 to some power of 2. Like if we cannot express 8 to the power 5 as 2 to the power m, no such m exists. We cannot find m such that 2 to the power m, we cannot find a integer m so that 2 to the power m will be equals to 2 to the power will be equals to 8 to the power 5, because no, sorry, I'm sorry, I am very sorry. So 8 to the power 5, please forget what I said just now. So 8 to the power 5 is nothing but 2 cube, 8 is 2 cube, and then we have to the power 5. So this is 2 cube whole to the power 5, which means 2 to the power 3 into 5, that is 15. So definitely 2 to the power 15 is not equals to okay. Now again, if you want to convert it with the base 4, since we are all having we are comparing, since we have expressed 4096 as 4 to the power 6, and so we have to check all other numbers choices with base 4, and then so we have seen that choice A 2 to the power 12 is 4 to the power 6, choice B is already given 4 to the power 6, and C 8 to the power 5 is 2 cube, this is 2 cube 8, and this is 2 to the power 15. Can we convert it? This is definitely not 4 to the power 6. This is definitely not 4 to the power 6, because we cannot, because we cannot convert, we cannot express this as 4 to the power something, because 2 to the power 15, 2 to the power 15 cannot be expressed as 4 to the power m. We cannot, there is no such m such that 2 to the power 15 is equals to 4 to the power m, because 2 to the power, for that if it was possible to express 2 to the power 15 as some power of 4, then we could have written it should have been possible to write 2 square and sum n equals to 2 to the power 15. If 2 to the power 15 could have been expressed as 4 to the power some power of 4, then we could have written 2 to the power 15 as 2 square and then whole to the power n, and this would mean that twice n equals to 15, but we know that twice n is an even number, and 15 is an odd number. So definitely this 8 to the power 5, which is equal to 2 to the power 15, cannot be expressed as any power of 4. So definitely, so 8 to the power 5 is not equal to 4096. So the answer is choice C. So 8 to the power 5 is not equals to 4096. My explanation was a little complex and a little lengthy, but I hope you got the idea, the strategy that we need to apply for to solve this kind of problem. Okay, this was question number 1. Let's see the next question. Arrange the following number in ascending order. Okay, so we are given some numbers in exponential form and we have to arrange in ascending order. Now to compare two numbers in exponential form, either it would be easy for us to compare to have either the base as same or the power same. Now we can see that the bases are different and also the powers are different, but we can definitely see that all the bases, that is 125, 625 and 25, can be expressed as a power of 25. So 125, so we know that 125 to the power 10 is equals to 125. We can write it as 25. No, I think it's better if we convert all these numbers in an exponential form with base 5, since all the bases in these numbers, that is 125, 625 and 25, can be expressed as a power of 5. So let's convert all these numbers as all the bases to power of 5. So we know that 125 is 5 cube. 5 into 5 into 5 is 125, and this is whole to the power 10. So this is 5 to the power 30, and 625 to the power 9 equals 625 is 25 into 25 is 625 and whole to the power 9. This is 25 square whole to the power 9. This is now 25 is 5 square, so we got 25. So 25 square equals 5 into 5 square. This is equals to 5 square. This is equals to 5 to the power 4. So 25 square equals to 5 to the power 4. So we can now write this as 5 to the power 4 and whole to the power 9. This is 5 to the power 9 into 4, 36. Now the last one, 25 to the power 16. Now 25 can be written as 5 square whole to the power 16. This is 5 to the power 16 into 2, that is 32. So we have the numbers as this, this and this. So the numbers are 5, 30, 5 to the power 30, 5 to the power 36 and 5 to the power 32. So all the bases are now same, and we now need to compare them based on the powers, that is the exponent. And clearly the ordering in the ascending order will be 5 to the power 30 less than 5 to the power 32 is less than 5 to the power 36. So the ordering is 5 to the power 30 was 125 to the power 10 is less than 5 to the power 32 was 25 to the power 16, and finally we have 625 to the power 9. So this is the ordering. So in this kind of problem where you see that the base we can convert all the numbers, all the exponents. By exponents I mean a number in exponential form. We can convert all the exponents to some same base, then we will convert them to that same base, and then we will compare the exponent, that is the powers, and based on the powers we can arrange them in ascending or descending order. Okay. Let's see the next question. Okay, so this will be a big problem, a lot of sub problems. So identify the greater number in each of the following. So we have to compare two numbers where all the two numbers are in exponential form. So we have 1, 2, 3, 4, 5, 6, 7, 8 such pairs of numbers we have to compare. we do we have any other question? Let me see. Question number 4. Okay. Let's do one by one. Question number 3. So A, we have to compare 2 to the power 6 and 6 to the power 2. So this is a very common problem where you will be given two exponents where each exponent where the base and the powers are reversed. The first exponent, the first number is 2 to the power 6 and the second is 6 to the power 2. So we can see that the base and the exponents has been reversed. Now which is bigger? Now usually it is seen that the greater number in the base turns out to be the greater number, but that is not always the case. There are exceptions. Now for this kind of problems, you can see that you cannot convert for comparison, as I mentioned in the beginning, that if you can convert the given two exponents either with the same base, then you just compare the exponent, or if you can make the power same, that is exponent same, then you just compare the base. Now in this case, let's see if we can make the exponent same. We just applying this this concept that a to the power m again to the power n equals to a to the power mn. Applying this concept, let's see if we can convert these two exponents so that they have the same power or exponent. So the first one is 2 to the power 6. 2 to the power 6 can be written as I can have 2 to the power 3, and then I can make a square. So I am trying to express 2 to the power 6 as a number in exponential form with a power 2. So 6 square is 6 square. So now we have so this is 2 cube, which is 8. So 8 square and 6 square. So we now have to compare 8 square and 6 square, and definitely we can say that this is greater because the powers are same. Now then we compare the base, and 8 is greater than 6. So definitely 2 to the power 6 is greater than 6 square. I hope it's clear. If you are having any kind of difficulty in understanding my methods or strategy or concepts explanation, then please do let me know in the comment section. If you have any kind of query, I will do my best to address your question and clarify your doubt. So in comparing these two numbers, the strategy that we are trying to apply is that we will try to convert the given two exponents. We'll try to express them in such a way that they have the same base or they have the same power. If they have the same base, then we will compare based on the exponent, and if they have the same exponent, we will compare them based on the base. Okay, so A is done. What is B? Let's see. B is 2 to the power 9. Compare between 9 square. Now in this case you can see that I cannot convert 2 to the power 9 in some form where in some exponential form where the power will be 2, because the power 9, 2 to the power 9, the power 9 do not have a factor 2. So in this case you have to expand it, you have to find the actual value. So in some cases of the problem, you won't be able to express the two given exponents to have same base or same exponent. So in those cases, you have to manually find the value of the exponent, that is by expanding. So 9 square is 81. 9 square is 81, and mm, 8 and 3. Okay, so 81 and 2 to the power 9. How much is 2 to the power 9? 2 to the power 9 is, we can say 2 to the power 3 and whole to the power 3. So this is 2 to the power 9. This is 2 to the power 3 is 8. So 8 cube. 8 cube is equals to 64. 64 multiplied by 8. This is 32 and 48. This is 512. So definitely this is greater than 81. So this implies 2 to the power 9 is greater than 9 square. So while I am solving the problem, you can pause the video and take screenshot, which might help you as a reference. So B is done. C. What is C? C is 7.9 multiplied by 10 to the power 4 and 5.28. This is 5.28 10 to the power 5. Now in this kind of problem, you see that both the numbers have a factor 10 to the power something. In the first we have 10 to the power 4, in the second we have 10 to the power 5. Now, and there is another factor, a number, a decimal number. So in this kind of problem, to compare, the strategy is that we would like to have the same power of 10 in both the numbers. We would like to have the power of 10 in both the numbers same. So what we can do is that let this number be the same, let 10 to the power 4, and since we have higher power of 10 in the second number, we can write 10 to the power 5 as 10 into 10 to the power 4. 10 into 10 to the power 4. So this becomes, this is 7.9 into 10 to the power 4, and this is 5.28 into 10 is 52.8 into 10 to the power 4. So now 10 to the power 4 is common factor in both the numbers. Then we have to just compare the other factor, that is 7.9 and 52.8. So clearly this clearly we have 7.9 since 7.9 less than 52.8 implies that 7.9 multiplied by 10 to the power 4 is less than 52.8 multiplied by 10 to the power 4. So this implies 7.9 multiplied by 10 to the power 4 is less than 5.28 multiplied by 10 to the power 5. So as a note, you can say that if we have this kind of numbers to compare, let's say x multiplied by a to the power m and y multiplied and you have y multiplied by, let's say, a to the power n. So x and y could be any number, and you have the factor a to the power m and a to the power n in the two numbers. So you would like to make the power of a same on both sides and adjust so and adjust the remaining part of the a to the power m or a to the power m. So the idea is uh, express express the numbers to have same power of a. So you make you adjust so from you have to adjust a to the power m or a to the power n in such a way that both the numbers have a same power of a, and then you can compare the rest factor of the two numbers. So I hope this problem is clear, how we the concept or the strategy that has been applied to compare these numbers. So since we have a power of 10, different powers of 10 in both the numbers, we would like to have we expressed both the numbers so that they have the same power of 10, and so the same power of 10 will be a common factor, and the rest part of the number in both the numbers will need to be compared. Okay. So C is done. What is D? 4 to the power 9 or 6 to the power 16 to the power 3. D is 4 to the power 9 or 16 to the power 3. So this should be easy because we can convert so we can see that the base are 4 and 6, 16, and we can convert them both we can convert both these numbers with the same base, that is 4. So this is 4 to the power 9, 4 to the power 9, and 16 cube can be written as 16 can be written as 4 square and whole cube. So this is 4 to the power 9 and 4 square is 16. We can write this is 4 to the power 6. So we applied a to the power m whole to the power n equals to a to the power m into n. So we converted 16 to the power 3 with the base 4. That was the whole purpose. So because the first number has base 4, now we see that the numbers have same base 4 and the powers are different. We see that 9 greater than 6 implies 4 to the power 9 is greater than 4 to the power 6. This implies 4 to the power 9 is greater than 16 to the power 3. Okay. E 7 to the power 4 or 5 to the power 4. This is easy. 7 to the power 4 or 5 to the power 4. Clearly, we know that if the exponent are same, we compare by the base. So 7 greater than 5 implies that 7 to the power 4 greater than 5 to the power 4. This is easy. What else? F is 6 to the power 3 or 4 to the power 4. 6 to the power 3 or 4 to the power 4. Now the we cannot make 4 cube. In these two numbers, we cannot create a same base. Neither we can create a same exponent, because the bases are 6 and 4. These two, 6 and 4, cannot be expressed as the same base. So 36. So since the powers are not so big, you can convert them. You can manually evaluate them, the exponents, into a number, and then check. So 6 to the power 3 is 6 into 6 into 6, and this is 16. 4 to the power 4 is 4 square to the power 2. So this is 16 into 16. Now, okay. So this is 6 into 6 into 6 is 36 into 6. This is 36 into 6, and this is 16 into 6 is how much? 196, I guess. 16 into 16 is 96, and 16. This is 6, 5, 256. 256, and 36 into 6 is 36, 216. 216. So 216 is definitely less than 256. This implies 6 cube is less than 4 to the power 4. Okay. G is 3 square or 15. 3 square or 15. This is pretty easy. I mean, 3 square or 15 is 3 square is 9. So I will write it here only. It's trivial to solve this. So 9 square, 9 is definitely less than 15. So this implies 3 square is less than 15. Okay, now H is 10,000 or 10 to the power 5. 10,000 or 10 to the power 5. Now 10,000 is 10 to the power. So this is 10 into 10. We have 4 zeros. Since we have 4 zeros, we know that a power of 10, if a number of the form 10, 100, 1000 like this, if it has n number of zeros, then it is equal to, so this will, so we know that, as a side note, a number, a power of 10, a number of the form 10, 100 or 1000, if it has let's say n zeros, n zeros, this is equal to 10 to the power n. This is 10 to the power n. Just you can check it. 100 equals 100 square, 1000 equals 10 cube, 10,000 equals 10 to the power 4, and so on. So we have 10,000, this is 10 to the power 4, and we can clearly see that 10 to the power 4 is less than 10 to the power 5 because the base 10 is same and the power 4 is less than the power 5. So this implies that 10,000 is less than 10 to the power 5. Okay. What else? Okay. So question 3 is done. Let's see question number, the last question, I guess. Yes. This is question number 4. It is asking which of the following has the largest value. So we are given 4 choices. Which of the following has the largest value? Now A is 0.0001, and we have studied decimal numbers, that how to convert decimal number into a fraction. So this, when we convert it into a fraction, is we have so when we convert a decimal to a fraction, what do? We write the numerator as it is. So this is omitting the decimal point. As numerator, the fraction, we write the decimal number by omitting the decimal point. So this becomes 0.0001 divided by the decimal places of the decimal number. The decimal places in this number is 1, 2, 3, 4. So divided by 1 followed by the number of zeros, which will be equal to the decimal places of the decimal number. So 4 zeros. Now this is nothing but 1 by 4 zeros, that is 10 to the power 4. Okay, so this is 1 by 10 to the power 4, and this is nothing but it's a reciprocal of 10 to the power 4. So we can say that this is 10 to the power 4. The reciprocal of any number is denoted by power of minus 1. This and this is equals to 10 to the power minus 4. Okay. What is B? B is 1 by 1,0,0,0. We have 4 zeros. Which of the following has the largest value? Okay. So this is 1 by, this is again equals to 1 by 10 to the power 4. This is same, B is same as A. So this is again 10 to the power minus 4. C, what is C? 1 by 10 to the power 6. This is nothing but the reciprocal of 10 to the power 6. Now this is following the rule A to the power m whole to the power n equals to A to the power mn. We see that this is 10 to the power minus 6. So the numbers we are having is 10 to the power minus 4, 10 to the power minus 4, 10 to the power minus 6. And what is D? D is 1 by 10 to the power 6 divided by 0.1 in fraction will be 1 by 10. It is 1 by 10. Now this we can write 1 by 10 to the power 6 is nothing but 10 to the power minus 6, and this is divided by 1 by 10 means 10 to the power minus 1. Now this we know that this is a division of two exponents, so this will be 10 to the power minus 6 multiplied by the reciprocal of the 10 to the power minus 1, which is 10. Now this is 10 to the power minus 5. So which is the largest. Mm. Why the choices A and B are the largest value is definitely 10 to the power minus 4. The largest is 10 to the power minus 4, but the choices A and B both are coming as 10 to the power minus 4. C is coming 10 to the power minus 6, D is the largest value. D is coming 10 to the power minus 4. So now we have, if we now compare the values of A, B and C, we see that the bases are same 10. We will now compare by the exponent. So the numbers in the choices are 10 to the power minus 4, and B is also 10 to the power minus 4, C is 10 to the power minus 6, and D is 10 to the power minus 5. So clearly we have two same numbers. The largest is these two, A and B. I am not sure whether I have the reference from where I have taken the question. I copied it correctly or not, because the choices A and B are same. One of the choices A or B should not be equal to 10 to the power minus 4. Anyway, so 10 to the power minus 4 is the largest one. So both A and B have the same value of 10 to the power minus 4. So the answer is A and B. Okay. So that was the last question. I hope this set of questions was beneficial to you in understanding how we compare numbers in exponential form, and the fundamental concepts, the theory behind the comparison is this. On the right hand side, you can take note of this. This is the basic concept, main concept, based on which we have to compare the given two numbers in exponential form, or we have to arrange a given list of numbers in exponential form, or even to find the equality of two numbers in exponential form. So that was it. Thanks for watching, and if you like this video, please like it, share it with your friends, and also please support me by subscribing to my channel, and that way it will help me grow my channel and motivate me to come up with this kind of videos on regular basis. And also please do not forget to press the bell icon so that you will be notified by my future videos. So in the next video I will start the next topic, that is on large numbers, expressing large numbers as exponents, and large numbers in standard form, and the square root, finding the square root of a number, and the cube root of a number, and that will bring an end to the top of the subject exponents. And after that I might prepare 2 or 3 sample paper that will cover a set of questions based on the whole chapter exponents, because it is very essential to have a good practice of lot of variations of questions in this on this chapter exponents, because it is very important. I mean, the concept of exponents will be heavily used in your higher classes, especially class 11 and 12. You must have a very clear understanding of the exponents. So once again, thanks for watching, and until the next video, take care and bye.